In this clip, we're going to learn the basics of rigid bodies in Unity. To begin, go to your Scenes folder and open M3-05_begin. In this scene, you can see that we have a crate full of barrels. And what we want to do is we want to apply a physics simulation to these barrels. To do this, we'll use the rigid body component. Let's select all of the barrels in our hierarchy panel, and let's add component physics rigid body. It's important to note that these barrels have a capsule collider applied to them. The capsule collider is fitting the form of the barrels, and this is going to ensure that we get the expected physics simulation with these objects. So let's take a look at what a rigid body component will do just by default. So if we hit play, you'll notice that these objects fall and they rest into place. It's also important to know that the fence objects for the crate, they also have a box collider on them, which is allowing them to stop the barrels. When a rigid body object comes to rest, it's important to know that Unity sets that object into sleep mode. Sleep mode is going to tell the physics engine that it no longer has to keep track of this game object. So this is a great way to optimize your physics simulations in game. So let's go back and turn off game mode, and let's take a look at the parameters of the rigid body. So the first parameter is mass. Mass is basically telling us how much stuff we have in an object. Some would say that that's the same as weight, but I think it's a little bit different. Let's say that we have these two barrels, and we set their mass to 1,000. What is going to happen is that these two barrels are going to push through any object that has a smaller mass. And so if we were to hit play, you'll see that we get an explosive result. So these objects are pushing their way through all of these barrels. It's important to know that even though they have a large mass, they can't push through an object that is not using a rigid body. So now that we have that, let's go ahead and take a look at the drag. Drag is a little bit different. Drag will simulate air resistance. And so what this means is that if we take this drag and we set it to 10, these objects are going to fall slower than the other objects. Now let's set those back to 0. Angular drag is very similar. However, angular drag is going to determine the air resistance on the rotation of an object. So if I were to set this angular drag to 10 and we hit play, the objects would fall at the same rate, but then they would begin to roll slower. It was a little difficult to see that here, so let's set it to something about 50. Let's hit play. You'll see that they'll hit, and then they really begin to roll through. They will still roll, but they're rolling at a slower rate. Think of this as kind of like a steamroller. Steamrollers move very, very slow, but they still have the mass, and they're still going to push through anything that doesn't have the same mass. So now let's take our angular drag back to 0.05 and hit enter, and then we're left with use gravity. Use gravity is pretty self-explanatory. It's either going to use gravity or it's not. Now that value is derived from the project settings. So if we go to Edit, Project Settings, and Physics, you'll see that right here is the gravity values. We can change gravity to use the X direction, the Y direction, which it is set by default, and the Z direction. In this case, it's pulling objects down in the negative Y direction at a value of negative 9.81. So if you want to change this value, you can. It's not going to tear anything up. You can do whatever you like in the game engine. Typically, we see gravity, the gravity multiplier even higher in a negative direction, of course, for side-scrollers and platformers. Typically, we see characters jump up really fast and then fall really fast as well. So let's go back to our barrels, and let's take a look at isKinematic. Now, isKinematic is a little confusing at first, but if we take a look at it systematically and some uses of it, I think it's really going to make some sense. isKinematic is going to turn on and off the rigid body parameters. So basically, it's still going to be used by physics, but it's waiting for a script to turn it on. So in this case, if I were to select this fence, I think it's fence 3, yes. Let's add a rigid body component to it. Now, in this state, if I were to hit play, the barrels are going to roll down and they're just going to bowl right through the gate. And I don't want that. I actually want some gameplay to where they're going to rest in place, the barrels anyway, and the fence is going to stop them. And I want to create a sense or a gameplay element to where the player hits the gate and then the gate falls down and the barrels come rolling out. What we can do is simply turn on is kinematic, and that would freeze the rigid body in place. So if I hit play, all other rigid bodies are still being blocked by this object. However, in gameplay, if my player were to come up and hit it, I could tell the script to tell this rigid body to turn is kinematic off. And when I do that, you'll see that the objects begin rolling through. So it's important to know that is kinematic is best used to create scriptable events. Is kinematic is also used on ragdoll physics. So our player may have ragdoll components added to it. And whenever the player health reaches 0, we just simply say is kinematic is turned off, and then the physics takes over the control of the character, and that causes that ragdoll type of effect. Now that we understand what is kinematic is, let's take a look at interpolate. Interpolate is a helper to smooth out jerkiness on objects that are being transformed through script, and they have a rigid body component added to them. Typically, we'll see interpolate used whenever a rigid body component is added to a player object that is being driven by the player input. So in this case, let's say that the player is pressing W, A, S, and D to move the character around our terrain. But the rigid body component is constantly pushing down in the Y to simulate gravity. And what's happening is we're getting this jerkiness that happens. And so what we can do is we can set interpolate to either interpolate or extrapolate. Interpolate is going to check the previous frame and smooth out the movement of the current frame based on that. Extrapolate is going to check the forward frame and try to smooth out the movement on the current frame. You'll have to experiment with one or the other to get the result that you're looking for. It's important to note that interpolate is not always going to solve your problem, but it can help. Beyond this, we have collision detection. Collision detection is really great because we may have rigid body components or objects that are moving very fast in the scene. Let's select this barrel right here and let's type in 180 in the Y direction. What this is going to do is it's going to cause that barrel to fall, and as it continues to fall, it's going to gain speed. So let's hit play and just see what happens. You'll see that our barrels kind of come into place, and then the barrel that's way up there comes in, and it actually bounces out. Now this appears to work as intended. Let's go to our scene view, and you'll see that it is in that crate, and it's resting as we thought it should. This is not to say that this will work every single time. Let's make a minor adjustment to this object. Instead of 180, let's do 180.7 and hit enter. Just a minor adjustment in the object is going to create a different result. And I'm going to explain why in just a moment. So here, let's take a look at our object, and you'll see that it has fallen through the crate and actually hit the terrain and then stopped. So what's happening here? What's happening is that the barrel is simulating physics falling down, and it's doing that every single physics frame. It's important to know that a physics frame is different than the frame rate of your computer. So in the game, there is an update frame, and that happens very, very quickly. But then there's a physics frame that still happens very quickly, but it happens at a consecutive interval or a consistent interval. And what we've done here is we've just proven that the barrel missed that physics frame whenever it collided with this object, but it collided with the terrain on the physics frame. And so what we can do for fast-moving objects like this is we could say, instead of using discrete, which is a slower physics frame, or a slower check of the physics frame, I should say, we could set it to continuous, which would look for that physics frame every single frame. So if I hit play on this, we're going to see this barrel come down, and it should hit that crate and work as intended. So just to check this, let's go to our scene view, and there you can see that it has collided with that object. Now sometimes the object might be going so fast that it won't even detect that, and you might need to use continuous dynamic. And again, this is just a faster rate in which collisions are going to be detected. It is important to note that the higher you go in this list, so continuous dynamic, it can create a large impact on your computations in your game. So typically what we want to do is we want to stay with discrete as often as possible. Now there should only be a few simple cases where continuous or continuous dynamic should be used. Now the final thing that we have in our scene is constraints. Constraints allow us to script physics simulations. So let me show you what I mean by this. Let's take our barrel and let's bring this back to 0 and then bring it back up into its original position. And with this, I want to think about how I want these objects to roll out of this frame, kind of like a trap, if you will. So let's say that we have a scenario where the player moves out in front of this trap and the gate falls down and then the barrels roll out. So let's just take a look at this really quickly. Let's take our fence and turn off is kinematic and hit play. The barrels roll out and they just kind of roll out in a mess. And there's no guarantee that it would actually hit the player. So what I would want to do is kind of guide the physics simulation. So on these barrels, let's make sure that we select all of them. I want to constrain the X position. So meaning I don't want the barrels to move side to side. So I can freeze that X direction. So let's hit play. And we'll see those barrels come out in that X direction. Now they are also kind of tumbling end over end in some of that. And I actually want them to rotate only in the Y axis. To show you what I mean by that, you can see that if we selected this object, you can see the Y axis is going around. I only want it to rotate in that Y axis. So I would need to freeze the X and the Z rotation. Let's select all of those barrels again. And let's freeze them in the X and Z rotation. Now if I hit play, you can see those barrels coming out and they're only moving in that direction. Now as you can see here, they got stuck on the side, and that's just because of the placement of the barrels. Let's grab our move tool by hitting W, and I'm just going to move that to the right a little bit. Now let's hit play, and that drops them in. Awesome. So now that we have taken a look at rigid bodies and how we can use them, let's move on into our next clip.